Hello, algebra students. Welcome back to another video lesson as we begin to explore chapter 12 on quadratics. And we look at graphing quadratics by hand and looking at some different forms that the equations might take. Today, we focus on the introduction to something called vertex form, which is this formula. You might want to write that down as vertex form. So maybe pause the video and write that down. But again, today we're going to identify characteristics of a parabola when it's written in that vertex form, when it's written like that. Now, before we get into that, I want to quickly review a little bit of a warm-up with you. If we are given this equation, y equals negative 3x squared plus 1, what are some of the characteristics that you can identify of this graph? For example, you should be able to tell me that it's a parabola, right? Anytime we have an x squared, it is a parabola. And because it's a parabola, it's going to open up or it's going to open down, depending on which value we get for a. Since it's negative 3, it will open down. What other characteristics do you know about this graph? Why don't you pause and jot a few things down and see what you come up with? All right, so here's a list that I came up with. So it is a parabola. It doesn't open up. It opens down because it's a negative value. Because it opens down, right? Wherever it is, if it opens down, that vertex is called a maximum. It's the highest point. And the vertex here actually has a vertex of 0, 1. Okay, right? It didn't move left or right at all. It's just moving up and down. It has a y-intercept of 1. Remember that c value, right? This is called c. It's also the y-intercept. Because we know the vertex is at 0, 1, we also know the axis of symmetry is x equals to 0. We know the domain left to right is all real numbers. We know the range here has to be less than the vertex, less than that y-intercept. We know that it's going to have 2 x-intercepts, right? If the y-intercept is up there at 1, that means it's going to cross the x-axis twice. And it's a little bit narrower than our normal graph of y equals negative x squared. So those are all things that we talked about previously in other chapters related to quadratics and parabolas. What we're going to get into today is investigating what happens when we have formulas that look slightly different, where our a value is out front and we have something called x minus h squared plus k. What happens when they are in vertex form? Now, in order for us to, I guess, really understand what's happening, we're going to use Desmos to graph, what do we have? 6 different functions, okay? And we're going to do it one at a time, just so that we can see maybe what's happening with these different components. All right, so I want you to pay close attention as we do this. So I'm going to go to Desmos, and I'm going to go to the graphing calculator. And this was part of your Desmos activity yesterday. But I want to start with just that basic one, y equals x squared, where it opens up. Okay, vertex was at 0, 0, and it opens up. Now, the second one has x minus 4 in parentheses with that whole thing being squared. So y equals parentheses x minus 4 quantity squared. What did you notice about that blue parabola by adding a negative 4, subtracting 4 on the inside? Notice it took it and moved it 4 to the right. So let's just jot that down. It went 4 to the right. Well, if it went 4 to the right by having x minus 4 in the parentheses, what do you think is going to happen with an x plus 2 quantity squared? Well, let's take a look. Okay, I'm going to get rid of that one that we just had, right? Minus 4 went 4 to the right. So now I'm going to change it from subtracting 4 to adding that 2, and noticed it moved it 2 to the left. right? The vertex moved over here to 2, 0, right? So this, let's make a column. Vertex. Our normal vertex for x squared is the point 0, 0. When we put subtracting 4 on the inside, it moved it 4 to the right, or 4, 0 was our vertex. So 0, 0 to 4, 0. Now it went 2 to the left. Right? By adding 2, let's go back to the graph, it went 2 to the left, and the vertex is at negative 2, 0. Negative 2, 0. So then, let's try a different one where we don't have parentheses, we just square the x value, and we subtract 5. So let's go y equals x squared subtract 5. Oh, well, would you look at that? It went from 0, 0, and it moved the vertex down 5 to 0, negative 5. So now, by adding the subtracting 5 out here, we went 5 down. So our vertex is now at 0, negative 5, because we went 5 down. So what do you think is going to happen if I change the subtracting 5 out there to an adding 3? Let's see. I should move up 3. And it certainly does. It moved it up 3 units so that the vertex is now at 0, 3. So 0, 3. Meaning we went 3 up. So here's my question, right? Each one of these we did separately. What happens if in equation 6, if I tie all of these together, where do you think the vertex is going to be located? So let's graph that. X plus 4 squared minus 1. And you got to make sure you use parentheses. X minus 4, that whole thing squared, minus 1. I think I typed it in wrong. Plus 4 minus 1. Okay, so, whoops. Plus 4, and I got to get rid of this x out front. That's better. X plus 4 squared minus 1, and look where the vertex is now. 4 units left and 1 unit down. Negative 4, negative 1. Negative 4, negative 1. So we went 4 units. This showed me 4 left and 1 down. So when it's inside the parenthesis, it's telling us to move left or right. And when it's that C value on the outside, that's the up and down change of our vertex. All right, so that's that exploration here and what's happening with the H comma K. All right, and that's really an important understanding. Okay, this piece in here tells us to go left, or it'll tell us to go right. If it's positive, we go left. If it's negative, we go right. This K value down here tells us to go up if it's positive, and to go down so many units if it's negative. So let's see what happens with a couple of examples. Without graphing, we're not going to go to decimals right now. List the vertex of each equation below, right? What's that vertex? So if we look at this one, y equals parenthesis x plus 5 squared. Inside it tells us to go left or right. And when it's positive, we're actually going left. So instead of being at 0, 0, we go left 5 or negative 5, 0. Letter B, y equals x squared minus 1. Well, that's our C value. It's on the outside. That tells us to go up or down. And in this case, we're going down 1 unit from 0, 0. So we go to 0, negative 1. All right? And remember, we always started at 0, 0. The regular parabola, y equals, oops, I don't want to go below the axis. Y equals right there, okay? Close as I can get it. That's y equals x squared. And so when we talk about how the vertex shifts or how it moves, we're relating it back to 0, 0. All right, 2 more. See if you can't answer those 2 on your own. All right, letter C should be a little bit more straightforward. Should be straightforward. This 2 is telling me, because it's positive, I got to go 2 left. -5 means 5 down. So if I go 2 left and 5 down, I'm at -2, -5. Now D is a little bit tricky. We don't have a 10, or we don't have anything out here, but we have a 10 over here, which means I actually should probably move that. By adding 10 to both sides, and then I can identify. And notice they've got an extra 3 out here for an A value. That doesn't really impact the vertex at all. That, remember, is telling us if it's going to open up or down and whether or not the graph will be wider or narrower. So I'm not focused on that for vertex. I'm just looking at this. And if it says x minus 3, right, the inside says left or right. If it's negative, that means we're going 3 to the right. If it's positive 10, we're going 10 up. 3 right and 10 up would be a vertex of 3, 10. All right, so I hope you see how those different values and where they're located are impacting your vertex. All right, if you have any questions, I would encourage you to please make sure that you reach out. You got another Desmos activity to complete today. Good luck. And until next time, everyone, stay safe.